Hello, my dear students. Myself, Devi Prasad Sir. Welcome back to you all to this chemistry class. In this video, you will be learning about the rest part of this chapter, metallurgy. Now, the transition metals. These metals lie between the reactive metals in group 1 and 2 of the periodic table and the poorer metals below the steps separating metals and non-metalloids. Characteristic properties. These metals have high melting and boiling points, which is much higher than alkali and alkaline earth metals. Unlike the soft alkali metals, these are hard and strong metals. Very high, these alkali metals have got very high densities, which is much higher than alkali and alkaline earth metals. Transition metals usually have colored compounds with colored solutions. We know that metals and non-metals can be differentiated on the basis of their atomic structure. The physical differences are dependent on the arrangement of the atoms, the chemical differences on the number of valence electrons and their behavior during chemical reactions, that is, ability to lose or gain or share electrons. Next, these transition metals do not react so quickly with oxygen and water. Most of the transition metals form more than one stable ion, each with its own series of compounds. Transition metals and their compounds act as catalysts. Transition metals are good conductors of heat and electricity. Compounds of transition metal, iron, that is iron oxide, is used as a catalyst in the Haber's process to manufacture of ammonia. Most of the transition elements exhibit variable valency, that means having more than one valency. The modern chemist has discovered ways of extracting metals, improving the quality of metals by alloying or mixing with other metals and protecting metals by electroplating. Although a few metals are found free or in the native state, the majority have to be extracted from their ores. The process of extracting the metals from their ores is well known as metallurgy. Then comes the inner transition elements. Lanthanides and actinides are called inner transition elements. These are placed at the bottom of the periodic table. Their actual place in third column, that's group 3 or 3b, and 6th and 7th period of the periodic table, and have properties similar to those of transition metals. However, unlike transition metals, most of them are radioactive. Modern chemistry has discovered ways of extracting metals, improving the quality of metals by alloying or mixing with other metals and protecting metals by electroplating. This already I said to you. Although a few metals are found free or in native state, the majority of the metals have to be extracted from their ores. That is a process called as metallurgy. Now, minerals and ores. Mineral. The compound of various metals found in nature associated with their earthly impurities are called minerals. Ore. The naturally occurring minerals from which metals can be extracted profitably and conveniently are called as ores. Metallurgy, the large-scale process involved in the extraction of pure metals from their respective ores is called metallurgy. Then comes matrix. The rocky impurities including silica, mud, etc. associated with the ore is called matrix or gangue. Then flux. The substance added to the ore to get rid of the matrix, resulting in the formation of a fusible compound is called slag. Now, ores of aluminum, zinc and iron. Ores of aluminum. Hydrated aluminum oxide, right? That is bauxite, right? Cryolite, sodium aluminum fluoride. Then comes ores of zinc, zinc blend, that is zinc sulfide. Calamine, zinc carbonate. Zincite, that is zinc oxide. Then ores of iron, hematite. The chemical name of hematite is iron 3 oxide. Then magnetite, its chemical name is tri-iron tetroxide. Iron pyrites, its chemical name is iron disulfide. The chemical formula of bauxite is Al2O3.2 water. That of cryolite is Na3AlF6. The chemical formula for corundum, it is also an ore of aluminum and the formula is Al2O3. The chemical formula of zinc blend is ZnS. Calamine is ZnCO3. Zincite is ZnO. Now, extraction of metals. The extraction of metals has got 4 important steps. Number 1 is concentration of the ore. Number 2 is conversion of the concentrated ore into its oxide ore. Then the third step is conversion of the oxide ore into its that is a reduction, and the fourth step is refining. Now, concentration of the ore can be done by any of the following 4 methods. The 4 methods are like this: hydrolytic method, magnetic separation, froth flotation method, and chemical method. Next, conversion of the concentrated ore into its oxide, which can be done by 2 different ways. That's by roasting or by calcination. Then the third step is reduction of the oxide ore, which can be done by any one of the following 3 methods. That is reduction by electrolysis, reduction by using the reducing agents. Third one, reduction by thermal decomposition. Then the fourth step is like this, that is refining of impure metal, which can be done by any one of the following methods. That is distillation, oxidation, liquefaction, and electro refining. My dear students, the rest part of this chapter you will get in the next video. I hope that you all understood the contents of this video. Thank you for watching and learning from this video.